Niaje tena wadau let's Teqcher fly tena hapa, nimetokea tena na kahesabu manze, na leo tunaangalia sketching and interpreting velocity time graphs, all under the topic linear motion. Hapo sawa? Nice one. Sketching manze ni different from drawing. Sketching inamaanisha I don't need to be exact and to be to scale. Lakini drawing, you must use a graph paper. Hapo sawa? Nice one. It is always important to sketch first before drawing your work on a graph paper. Example inasema a car accelerates uniformly from rest to a speed of 30 meters per second in 15 seconds. It then travels at this speed for 10 seconds before the brakes are applied and uniformly comes to rest after a further 10 seconds. Unaambiwa sketch the velocity time graph. Nataka kwanza to sketch the velocity time graph and then we see what happens. First of all, ni kuambie kwamba ukiambiwa velocity time graphs inamaanisha velocity is on the y-axis and time is on the x-axis. So first of all, unaandika hapa velocity. We know that the unit of velocity is meters per second, and then time on our x-axis, and in this case we can see that time is in seconds. So time is in seconds. Hapo sawa? Nice one. Ni rahisi sana manze. Alafu sasa unaanza tuanze nayo kudeal nayo virahisi sana. A car accelerates uniformly. Uniformly inamaanisha with a straight line, haichange, ni moja. Kama ni 10 meters per second square acceleration, ni hivyo, haichange. So accelerates uniformly from rest to a speed of 30 meters per second in 15 seconds. Okay? So tunaambiwa ina travel in 15 seconds, ina travel at a speed of 30 meters per second. Hapo sawa? Nice one. So nikiangalia vizuri hapa, the maximum speed is 30 meters per second. So kuja, the maximum velocity, that is 30 meters per second. So kuja hapa and then make your scale. Acha yangu ikuwe 10, 20, 30, 40 hivyo, ziachane na 10 kwa yangu. And of course you can see this is all velocity in meters per second. And then this is time. I can see that time iko hapo, so make your own scale. I want to use a scale of 5, difference of 5. So 5, 10, 15, 20, 25, 30. Then I can have 35 over there. Hapo sawa? Nice one. So ninaambiwa car accelerates uniformly from rest. From rest ni from 0 to a speed of 30 meters per second in 15 seconds. So kuja hapa kwa 15 seconds because that is time. So 15 and 30 zinakutania wapi? Zinakutania hapo. So it is accelerating uniformly. So if it is uniformly, then we draw a straight line. Tunashikanisha from rest up to here. Shikanisha with a straight line. Remember, I am sketching. When you'll be drawing, use a straight line with a ruler. Use a ruler to draw the straight line. So ndo hiyo accelerate uniformly at 30 meters per second in 15 seconds. It then travels, alafu kutoka hapo ina travel at this speed for 10 seconds. So inaendelea na hii speed ya 30 for 10 seconds. So 10 seconds, 15 plus 10 inatupea 25. So paka hapa kwa 25, speed haichange. Speed kama haichange, hii inakuwa flat ama horizontal. Because you are traveling at 30 meters per second for the next 10 seconds after 15 seconds. 10 plus 15, 25 seconds. So hadi hapo speed ni 30. So you flatten the curve. Okay? Before the brakes are applied, so alafu brakes zinaekwa, No. Tunaambiwa it then travels at this speed for 10 seconds before the brakes are applied. Okay, and uniformly comes to rest. And uniformly comes to rest after a further 10 seconds. So alafu brakes zinakanyagwa, alafu inaanza kuja to rest. So to zero in 10 seconds. So tuko kwa 25 seconds. Add 10 seconds, utafika kwa 35. Yes. Utafika kwa 35. And this happens. And this is to rest. To rest is to zero. So hii line ya zero. So unashikanisha hapo. Again, you can use your ruler. Use your ruler, shikanisha namna hiyo. As you can see, sasa inakaa kitu kama hiyo. And this is a trapezium, as you can see. Hapo sawa. Nice one. So we have successfully sketched a velocity time graph. So remember, ukisha sketch hivi, now go and draw a proper one that is drawn to scale in a graph paper. Sasa let us interpret a velocity time graph. Ukiona velocity time graph kama hii, ni nini tunaweza pata hapa? There are two things that I want you to know. The first thing that I want you to know is what is called gradient. And the next thing that I want you to understand is called kuna gradient na kuna the area under the velocity time graph. Area under ni area ya hii shape. Gradient ni kama vile tulifanya. Gradient is so simple. How you get gradient. Okay? Now, to get acceleration and deceleration, we get gradient. To get the total distance traveled by the car, we get the area under the velocity time graph. So the velocity area under the velocity time graph will give us total distance traveled. The gradients will give us both acceleration and deceleration. Umeshika hizo manze, sasa uko fiti. Sasa unaulizwa hapa sketch, tusha sketch. Unaulizwa calculate the acceleration of the car. Remember, ili accelerate kutoka hapa hadi hapa. Huku ilikuwa deceleration. Because kudecelerate ni kupunguza speed na kurudi kwenda pole pole. Ku accelerate ni kupanda speed. So it accelerated from 0 to 30. So in 15 seconds. So this is, hapa ndio acceleration ilikuwa. To get acceleration, we get the gradient is equals to change in y over change in x. Change in y will be 30 because remember, this is 30. 30 minus 0. Tunatafuta the gradient of hii shape. So 30 minus 0. This is meters per second because that is the unit for velocity divided by the change in x. Change in x tunaipata kwa hii line 15 minus 0. And this is seconds, in seconds. Okay? So this will be 30 minus 0 is 30 divided by 15 minus 0 is 15. This is meters per second and na hii hapa chini ni second. So this will be 2 meters per second square. Meters per second square. That is our acceleration. I hope umeona. See our deceleration or retardation. Deceleration and retardation is the same thing. So the deceleration or retardation again will be change in y over change in x. But where does deceleration occur? Deceleration ina happen hapa. For the next, tuliambiwa, the brakes are applied and uniformly comes to rest after further 10 seconds. So ilikuwa hapo. Hapa ndio brakes ziliapplywa. So get the gradient there. Change in y will be 30 minus 0 meters per second. because hapa ni 30 na hapa kwa hii line ni 0, divided by the change in x which is 35 minus 25. This is in seconds. 30 minus 0 is 30. 35 minus 25 is 10 meters per second, 90 seconds. So 30 divided by 10 is 3 meters per second square. So the deceleration is 3 meters per second square. Right. You can also say the acceleration here was negative 3 meters per second square, but the deceleration is 3 meters per second square. Lastly, tunaambiwa calculate the total distance traveled by the car. Remember nimekuambia the area under the velocity time graph will give you the total distance. So D, kupata distance ya hii shape, unajiuliza what shape is this? It is a trapezium. How do you get the area of a trapezium? Area of a trapezium is a half A plus B multiplied by H. What is our A? Our A is here. Our B is from here to here. So this is our B. Hapo chini namna hiyo. This is our A hapa juu namna hiyo. And this is our height hapa. So A is hapa hadi hapa. Tulipata ni 25 minus 15 ni 10. 25 hapa minus 15. It is 10. So a half multiplied by 10 plus B. What is B? B ni kutoka hapa hadi hapa, which is 35 minus 0, which is 35. Then our height is kutoka hapa hadi hapa, which is 30. So multiplied by 30. My dear friend, this will be a half times 45 times 30. Ukifanya vizuri, you should be able to get that this is 45 times 15, which is 675 meters. I hope umeelewa. It is so simple. Bye.